Composition of functions. So we've seen this function notation, f of x is equal to 3x plus 2, and we know how to find the value of our function when x is certain values. And the way we find that out is we substitute that value in, and we can find our value for our function. For example, if x is equal to 3, we find f of 3, and that's equal to 3, and we replace the x with a 3, times 3 plus 2, or 9 plus 2, which is 11. Now remember, this doesn't mean f times 3. This is just the way we notate our function notation. Now we can do the same thing. We can actually find the value of our function when we substitute in another function for our x value. So we find f of g of x, for example. So if we were to find f of g of x, what we're doing is everywhere there's an x, we're going to substitute it in. Instead of a specific value, we're going to substitute in another function. So instead of 3 times x, we have 3 times g of x plus 2. Now if we say our g of x is equal to x squared in this case, we can substitute in x squared for our g of x. So f of g of x, this is another way to write f of g of x. It looks kind of like fog, but what that 0 really is, or that circle really is, it's not a 0 and it's not an O. It's just really like an open dot. So it actually should be a little bit smaller than that. But that's another way of writing f of g of x is equal to 3 times, and instead of g of x here, I'm going to substitute in what my function is. It's x squared plus 2. And then I can go ahead and I guess I'm not distributing, but really just multiplying there. So f of g of x is equal to 3 times x squared plus 2. So it gives me a different kind of parabola. Now if we were to take g of x, we could find g of 3, so we could find the value of g of x when x is equal to 3, and we would just substitute in a 3 for my x values, and we'd have g of 3 is equal to 9. Now if we wanted to find g of f of x, we're going to instead replace of our x, we're going to replace an f of x in there. So that would be f of x squared. Now f of x is just a function, so we're finding the value of a function. So at f of x, so f of x is equal to 3x plus 2. So g of f of x is equal to 3x plus 2, my f of x, just substituting it in there, squared. Now when I have a function like this, and I'm squaring it, I really have to expand it. So that's 3x plus 2 times 3x plus 2, and I'll go ahead and distribute. I get 9x squared here, and then I have a 6x plus another 6x, which gives me 12x, and then plus a 4. 2 times 2 is 4, so as I distribute that 2 over here. So my g of f of x is equal to 9x squared plus 12x plus 4. Let's take a look at a few more examples. So this time I have a different f of x and a g of x, and I also have an h of x. So say I wanted to find g of f of x, and I like it in this notation, you may like it in this notation, but this one gives me an idea of what value I'm substituting in. So that means I'm going to take my function g, and everywhere there's an x, I'm going to substitute in f of x. So here's my function g of x is equal to 4x minus 1. And instead of the x, I'm going to replace it with my f of x. So g of f of x is equal to 4 times f of x minus 1. So my g of f of x, I can just substitute what f of x is. So f of x is equal to x squared plus 4. So instead of f of x here, I have x squared minus 4. Did I say plus 4? That's a minus 4. So 4 times x squared minus 4 minus 1. And then I'm going to go ahead and distribute the 4. So I have a 4x squared minus 16 minus 1. And then I'll go ahead and simplify by adding like terms. And so my g of f of x is equal to 4x squared minus 17. Now let's say I want to find my h of g of 3. So instead of x, I'm finding h of g of 3. So I can rewrite it like this, h of g of 3. So I really want to find what g of 3 is, and then I can evaluate it in my function h. So g of 3, I'm just going to take my g of x, and I'm going to replace the x with a 3. So 4 times 3 minus 1. 4 times 3 is 12, minus 1 is 11. So I know g of 3 is equal to 11. So I'm going to find h of g of 3, which is the same thing as finding h of 11. So I'm going to take that 11 and I'm going to substitute it in for my x value in h of x. So here I have h of x is equal to 3x, and I really want h of 11. So h of 11 is equal to 3 times, I'm going to replace the x with 11, is 33. So my h of g of 3 is equal to 33. Okay, so I have my same values again for f of x, g of x, and h of x. My functions are the same. Now what if I wanted to find h of f of g of x? So h of f of g of x, I could rewrite it here just like this. So I'm taking my h of f of g of x. And so first I'm going to find out what my f of g of x is. I'm going to break it down and then I'll find h of that. So f of g of x, I'm just going to take this section and figure out what it is over here. So f of g of x, that means I'm going to take my function f, and everywhere there's an x, I'm going to replace it with a g of x. So here's my function f of x, and instead of an x right here, I'm going to put g of x squared minus 4. G of x is 4x minus 1. So instead of g of x right here, I'm going to replace it with what g of x is, just 4x minus 1. So I have 4x minus 1 squared, my x is squared, minus 4. I'm going to go ahead and expand this so that I can combine like terms. 4x minus 1 times 4x minus 1 minus 4. And then distributing, that's 16x squared. And then I have a negative 4x and another negative 4x, which is going to give me a total of 8x. And then negative 1 times negative 1 is just positive 1 minus 4. So I have 16x squared minus 8x minus 3, adding that 1 and that negative 4, minus 3. That's what my f of g of x is. So now I can take that and I can substitute it in for f of g of x. So I want to find h of f of g of x. So I look at my h of x is equal to 3 times x, and everywhere there's an x, I'm going to put my f of g of x. So 3 times f of g of x. Well, I know what f of g of x is. I found it over here. So instead of f of g of x right here, I'm going to substitute this value in. So I have a 3 times 16x squared minus 8x minus 3. Distributing the 3, that's 48x squared. 3 times 16x squared is 48x squared minus 24x minus 9. So h of f of g of x is equal to 48x squared minus 24x minus 9. Now if we look at some of our special composition functions, it's an iteration. And an iteration is a composition of a function with itself. So for example, if we want to find f of 4, if f of 0 equals 2, and f of n, with some number n, is equal to f of n minus 1 plus n. So see, that function is composed with itself. F of n depends on what f of n minus 1 is. And then we add that value n, so that's some number. So for example, if we wanted to find f of 1, so we know f of 0 is 2, that's given right here. If we wanted to find f of 1, we know that's the same thing as f of n minus 1. So f of n, we're going to find our n is 1 right here. 1 minus 1 plus 1. So this f of 1 minus 1 is the same thing as f of 0 plus 1. F of 0 we know is 2. And then I'm going to add another 1. So that gives me 3. So my f of 1 is 3. Now if I wanted to find f of 2, that's the same thing as my n is equal to 2. That equals f of n minus 1, so 2 minus 1, plus n, so plus 2, and that's equal to f of 1, 2 minus 1 is just 1, plus 2. We know what f of 1 is from over here. That's a 3. So we have 3 plus 2 is equal to 5. So my f of 2 is 5. Now, of course, I'm going to use that f of 2 to find my f of 3. F of 3 is equal to f of 3 minus 1 plus 3. F of 3 minus 1 is the same thing as f of 2 plus 3. F of 2, remember, was 5, so we substitute that value back in. Plus 3 is equal to 8. F of 4, which is really our goal here, my f of 4 is equal to f of 4 minus 1 plus 4. F of 4 minus 1 is just f of 3, which we know from right here, plus 4. So that 8, that f of 3 plus 4 is equal to 12. And I found my value, f of 4 is equal to 12. And that's a special composition function. That's a function composed with itself, and that's called an iteration.